Good morning, everybody. This is Michael O'Brien with the Fire and Life Safety section of the IAFC and board director with the International Association of Fire Chiefs. With me is Chief Andy King, the chair of the Fire and Life Safety section. And we're bringing you another installment today with our great partnership with NEMA and their Fire Life Safety group. This partnership's been pretty long-standing, and it's allowed us some great access to some very passionate individuals across the entire world and experts in fire alarm systems. And we know as fire chiefs, if you've been paying attention to our series, that we are trying to get you the tools so you can respond to alarms and help work with an alarm system and be really educated. We know that the demand on our fire service to be experts in a lot of areas can be quite overwhelming. And today we're going to take a look at notification appliances. I'm going to hand it over to Andrew with Honeywell, who has a unique experience and expertise in notification appliances. So Andrew, the floor is yours.
Thank you, Chief. On behalf of NEMA, we express our thanks for this opportunity to continue to present information on fire alarm systems. And today we're going to be talking about the three types of fire alarm and signaling system notification appliances that are used to alert groups of people to fire or other emergency conditions inside of buildings. There's another presentation on mass notification and emergency communication systems that will be covering the use of notification appliances to alert people in a lot of other places. So we'll discuss audible, visual, and speaker notification appliances, and then we'll have some time for questions and answers. Next slide. So audible notification appliances are alert people to events using sound. There are many varieties of these devices in use, and they produce many different alerting signals. There are horns, bells, chimes that produce various tones, but do not produce voice messages. Special audible notification appliances that produce a low frequency output of 520 hertz are used in sleeping areas. This is because research has shown that this lower frequency signal is more effective in waking individuals, including older people, the hard of hearing, and alcohol drinkers. Next slide. So when evacuation within a building or part of a building is required, the audible notification appliances are used to play the temporal 3 pattern, which uniquely indicates the need to evacuate. The temporal or temp 3 pattern is not used for anything other than evacuating an area. It can be delivered on any audible notification appliance and consists of a tone, chime, or bell that is activated 3 times with a duration of on for half a second and off for half a second each time. And after the 3 activations, there's a pause before the sequence repeats. There is another unique audible signal called the temporal 4 pattern, and it's produced by the audible notification appliances when poisonous carbon monoxide gas is detected by a detection and signaling system. This signal is different from the evacuation signal because it has 4 pulses that are 5 times faster than the evacuation signal pulses. And the 5-second pause before the 4 pulses in the temp 4 signal repeats is almost 4 times as long as the evacuation signal pause. Next slide. Because all people do not have equal hearing ability, notification appliances that alert using our visual sense are also required. These visual notification appliances use visible light to produce an alerting signal. The simplest alert is the flashing of a strobe light at a rate between once every half a second and every 1 second. This rate is important so as not to affect persons that have visually triggered epilepsy. Also, the flashing lights are synchronized so that they flash at the same time within the same area to avoid triggering a visually induced epileptic seizure. Because the Americans with Disabilities Act, which requires equal facilitation for all building occupants, the visual and audible notification appliances are required to be activated and deactivated together. The strobe lights may alert occupants by direct viewing, so they can see the light directly, or indirectly by the light reflecting off of surfaces in the room. and colors can be used to differentiate between different kinds of signaling events. Next slide. Textual notification appliances can be used to supplement strobe lights so that the deaf or hard of hearing can visually receive a more detailed message about the situation. The textual notification appliances are often used for other purposes during non-emergencies, including for video entertainment and advertising. They automatically switch to provide visual text messages and/or graphics in an emergency. Next slide. Where voice messages are required or desired, loudspeakers, often referred to as speakers, are used. Speakers can also produce a variety of tones, so you don't need both the non-speaker type of devices in addition to the speakers. Just the speakers will take care of things. Voice messages delivered by speaker notification appliances can provide very specific information regarding the particular situation that might include fire, weather, security, health, or other emergencies. The messages played can include specific information regarding what actions to take and when to take them as required by the particular situation. And the messages may be pre-recorded or delivered live. The temp 3 pattern that was described earlier always precedes any voice message associated with evacuating an area. The voice message, if provided, gives more details about the situation and what to do when leaving the area. The message might, for example, remind occupants to use the stairs and not the elevators when leaving. All audible notification appliances are required to be arranged so that they are loud enough to be heard over the typical ambient noise within an area. When this is hard to achieve, the alarm system may automatically deactivate loud machinery or other noisy equipment in the building. And another important parameter is intelligibility. Messages need to be intelligible, which means that the message must be understandable. And intelligibility is evaluated as part of the system design, installation, and commissioning. So in summary, we've learned about how fire alarm and signaling systems use audible notification appliances to alert using the sense of hearing, visible notification appliances that use light to alert people, and loudspeakers that can deliver voice messages specific to the situation. Are there any questions?
You know, Andrew, I was wondering what happens sometimes, every now and then when we go on a fire alarm, it might sound like a duck. It doesn't sound like a fire alarm. What do you think? What should we tell the building owner to do in those cases when it just isn't sounding like a horn strobe with that traditional sound?
So if the audible aspect of the fire alarm system is sounding less than it should in terms of its characteristics, you should contact your service technician to have him evaluate what the problem is. And there could be any number of problems, including a problem with the voltage being applied to the unit or something to do with the connection to the unit. And it needs to be evaluated by a professional skilled in understanding the various aspects of that.
And do you see any major trends changing within the industry as it relates? I mean, horn strobes have kind of been around a lot, right? We're seeing a lot more speaker strobes or speakers on the notification circuits. Do you think the trend's going to be with more visual displays or anything else?
I think the trend is going to be continuing to include more voice systems so that you have specific instructions regarding what to do in a particular emergency, and there'll be more supplementation with the textual signage so that you have equal notification for those that are hard of hearing.
Fantastic. I know we have some other listeners on the call. Any other questions for Andrew on notification devices?
Chief, it's Andy King. I wanted to ask a question for fire departments. Obviously, when we choose to silence an alarm and choose to silence the notification appliances, sometimes we see those react different ways. In the old, I say old days, probably when I was riding an engine, we would see the strobe or the LED continue to flash in some cases, even though we had a silence. Now today, when you hit silence, sometimes the horn strobe and lights and everything goes out completely upon silence. Does anybody else listening on the group want to explain what we're seeing and why we have differences besides the time period they were installed in?
So again, this has to do with the Americans with Disabilities Act and the equal facilitation requirements to cover the cases of all people with disabilities so that they all have the same warning regarding what's going on. So if you turn off the audible, but the visible is still indicated, then you're signaling to those who are hard of hearing a different message than those who are not. And that's the basic background behind why they all go on and off together now, and that there should be other mechanisms to prevent people from returning to the building other than leaving the flashing lights on.
Great, that's a good explanation. Thank you.
Well, Andrew, thank you again for your time today, and thanks again for the partnership on behalf of the section with NEMA. This was just another great example of how we can help prepare our firefighters to respond to incidents where fire alarm systems are involved. We want to thank you for your time. We thank you for the partnership with NEMA, and we hope everybody has a great day, and we'll see you on the next educational session.